some important questions based on electrostatics. First question is, sharp and pointed end of a conductor has infinite charge density. Explain. Sharp and pointed end have negligible length and area of contact. So due to negligible length and area of contact of the pointed end, its charge density is infinite according to the formula linear charge density lambda equals to Q by L and sigma equals to Q by S. When L and S both tends to 0, then lambda and sigma both tends to infinity. Second question is, what is the value of electric potential at the equatorial point and at the midpoint of the dipole? Answer is 0. Since equatorial point and midpoint are equidistant from the charges whose magnitudes are same, so according to the formula, V equals to KQ by R, net voltage at the given points becomes 0. Third question is, quantization of charge is ignored at macroscopic level. Explain. At macroscopic level, the value of charge is very large, very huge. And if certain number of charges are transferred from one material to another material, whose charge magnitude of charge is negligible, is very less, and if this is subtracted from the charge which is present in the macroscopic object, net charge on macroscopic object will remain unaffected. So if certain amount of charge is either removed or added, net value of charge on macroscopic object remains same. And that is why we used to say that quantization of charge is ignored at macroscopic level. Third question is, what are the two positions where electric field due to a charged hollow sphere? What are the two positions where the electric field due to a charged hollow sphere is 0? First is inside the charged hollow sphere, where there is no charge. And second, at infinity, where electric field is 0. According to the formula, E equals to KQ by R squared. When R tends to infinity, E equals to 0. So 2 points are inside point and at infinity. The next question is, what is the electric field between two parallel plates having equal and opposite charge densities? The answer is sigma by epsilon naught, where sigma is surface charge density, which is equals to Q by A, area of each plate. So the electric field between the two parallel plates will be E equals to Q by A epsilon naught. Next question, why is the net field inside the conductor placed in uniform electric field is 0? As you know that when any conductor is placed between in an electric field, between two plates having equal and opposite charges, then polarization takes place. And due to polarization, electric field is induced inside the conductor whose direction is opposite to the applied field and magnitude is same as applied field. So due to equal magnitudes of applied field and induced field and opposite direction, net field inside the conductor becomes zero. Electric potential remains constant throughout the volume of a conductor. Explain. Electric potential remains constant. As we know that inside there is no electric field, so E equals to 0. So from E equals to dV by dr equals to 0, and therefore V is constant as differentiation of constant is 0. The next point is, what is electrostatic shielding? This is the process of protecting electrical appliances from the external field. 1 farad, next question is 1 farad of capacitance is a huge value. Explain. If we want to make a capacitor of 1 farad capacitance with a very small separation, that is nearly 1 centimeter, then we will require 2 plates, each of area nearly equals to 10,000 square meter. Or in other words, we can say that it will require 2 plates, square plates, each of length nearly 30 kilometers. And the capacitor having plates of this length cannot be constructed. If they are constructed, they cannot be installed at a place. Next question is, give example of a point where E is 0 but V is non-zero. E is 0 at neutral point. When we take a system of 2 equal charges separated by some distance, then at the midpoint, electric fields due to both the charges will have same magnitudes and opposite directions. The net field at that point will be 0. Whereas the value of V will be 2 kq by half the separation between the charges. So at the midpoint of the system of 2 equal charges having same nature, E is 0 but V is non-zero.